Hello, welcome back to another episode of Math with Haas. You're watching Precalculus Season 2, Episode 32. We are continuing our investigation in trigonometry, and now we are going to derive the sum to product identities. So, if we recall our product to sum identities, which we derived in the last video, we had sine alpha cosine beta is equal to 1/2 times the quantity of sine of the quantity alpha plus beta plus sine of the quantity alpha minus beta. And we had sine alpha sine beta is equal to 1/2 times quantity of cosine alpha minus beta plus, oh no, that needs to be minus cosine of alpha plus beta. And our last one was cosine alpha cosine beta is equal to 1/2 times the quantity of cosine alpha plus beta plus cosine of alpha minus beta. Alright. So, how we're going to derive our product to sum, or sum the product identities, is we're just going to reverse engineer these three identities, essentially. So, the first thing we want to notice is inside each, So inside each of the quantities on the right side, we have either alpha plus beta or alpha minus beta. In fact, let's just emphasize with the blue all the alpha plus betas, and we can emphasize with pink all the alpha minus betas. So what we could do is say, well, if alpha plus beta is equal to some quantity, we'll just call it u. And let's just say alpha minus beta is equal to some quantity, and we'll call it v. Then we can start rewriting this. So if we want to figure out what, say, u plus v looks like, well, that's going to be alpha plus beta, because that's u, plus, and let's emphasize, so that's u. And then we have alpha minus beta, that's our v, which is 2 alpha. In other words, this is telling you that alpha is equal to u plus v over 2. And we can do the same work where if we did u minus v, you would find that beta is equal to u minus v over 2. Okay. So notice now, so we have the sum and subtraction of alpha and beta equaling u and v, and now we have a representation of alpha and beta in terms of u and v. So what we can do is now do substitutions of our alphas and betas inside these three identities to get our new ones. So for example, let's see here, we'll zoom out a little bit. So for the top one here, we'll do this work in blue. So if we change all the alphas and betas in terms of u's and v's using what I just boxed in red, then we know that sine of alpha is the same thing as sine of u plus v over 2. And cosine beta has to be u minus v over 2. And that's the left side. And on the right, we have our 1/2 still, times quantity of sine. Now alpha plus beta is just u. And then we have sine of alpha minus beta, which is just v. So then if we multiply both sides by 2, you get 2 times sine of u plus v over 2 times cosine of the quantity u minus v over 2. And this has to equal, let's write that better. There we go, sine u plus sine v. And this is actually our first identity. And the derivation is as simple as that for all four. So we'll zoom in now, and we'll just list them. So the four product to sum identities. So we have sine of u plus sine of v is equal to 2 sine of u plus v over 2 times cosine of u minus v over 2. So that's the one we just proved. And very similarly, we could have shown that sine of u minus sine of v is equal to 2 times sine of u minus v over 2 times cosine of u plus v over 2. This one would be very easy to prove just by plugging in a negative quantity in for v in the top one. So instead of a positive v, if you had like a negative v, then it would immediately follow from the even odd properties. And then we have cosine of u plus cosine of v is equal to 2 cosine of u plus v over 2 times cosine of u minus v over 2 and cosine of u minus cosine of v is equal to negative 2 sine of u plus v over 2 sine of u minus v over 2. Alright. With that, thank you for watching our video. Thank you for joining our math party. If you've been enjoying our content, please subscribe and consider supporting us financially on Patreon. And with that, you will get some cool perks while being able to help me dedicate more time to this project. Thank you again, and I will see you next time.